Hello, Internet. I recently moved to a new apartment and have a little bit more space than I did in the previous one. I'm still getting everything set up, so audio might be a little bit weird and lighting's probably all screwed up, but I'm figuring that out. I have more space now, and I kind of want to fill that because I don't have anything to fill it right now. And so one of the things that I've been kind of inspired by is Robin Baumgarten's Line Wobble, which is a single one-dimensional game that's played on an LED strip. And so you can get these strips. One of the coolest things that I saw with this is it was actually put into a subway station, subway station in the UK. And so they just had a giant Christmas tree with this game on it, and anybody that was there could play it. And so I kind of want to do that and create some like interactive features throughout my apartment, just to kind of help fill the space, but also kind of create more interesting things. And so I've never done this before. Like we've played with like embedded things before. We've done LED strips and Arduino stuff before, and we've done Unity stuff before, but we've never combined them. We've never combined a game and like real stuff. And so I'm kind of curious to see how that's going to go, because it's a very different thing. Like with a game, you just have your screen, right? We just have this, whatever you're watching this on, and that isn't real, or that isn't like the reality once you actually break out of that. Like if we start putting an LED strip on something, we can make it do whatever we want. We can make it go in loops, we can make it do circles, we can do pretty much anything. Like we're not constrained to this 2D flat panel anymore. And so I'm kind of wanting to experiment with some ideas. That's why we have Unity open here. I feel like this is a good medium for us to kind of explore these ideas and build something. What I'm thinking is I want to build a circular table and then fill that with sand. And so the idea is we're going to have the sand table, sort of like Zen, like sand or rock garden style. And we're going to put like a steel marble in there. And then we're going to have a magnet underneath it. And the idea is you're going to use that magnet to move the marble through the sand. And this will leave a trail behind you. And then the idea is that can just kind of run, and you'll be able to see like a pattern get traced into it. But also you can play it. And so I'm thinking we're going to have like two axes. And so we're going to have like the long arm. And then if you've ever used those, I don't remember what they're called, the gear things, where you would stick like your pen or something in there and trace one gear inside the other and create like these spiral shapes. Honestly, it's been a very long time since I built something like that, but I want to build that in this like rock garden style and insert some like LEDs and things. I have no idea if this is going to work. Like the initial concept I'm thinking of is like a circular like Fourier transform thing. And so we're going to try to like build that initial movement thing. And then we'll go from there and then figure out if this makes any sense, if this is a good idea. And then the end product is actually going to be like making it real. We're like actually getting the hardware, constructing the table, and doing all of that. That's a long way away. But we can start here, and this will probably go much faster. And we can actually prototype here and then figure out what we need, what a good size would be, and all of those other things. We might even be able to like pull in VR and actually be able to like compare that and like place it in a room and see how it actually looks. So I know it's all really abstract, and I'm like waving hands, and it's just hand waving, really, like literal hand waving. But it's the best I've got. So we'll see what happens here. But basically, what I'm thinking is we can do. Let's see here. Let's take a cube and drop this in and just make it sort of long. So like this is the first arm. And then what we're going to do is create a pivot point at the very end of it. It's gone. Oh, we scaled our cube. Let's not build it like this. Let's create an empty game object, and let's add our cube this way. And so the reason I'm doing it this way is we're not going to scale everything with the cube. Like we're going to have our visual effects, and then we're going to have our like physical aspects to the thing. I feel like that's an easier way to do this. We could not worry about that, but it's, for me, it's easier if we just keep everything in normal. That's not the right thing. In actual dimensions. So we've got this thing at position 5 now. So our initial arm is going to be 5 units long, or 10 units long. And then we need a shorter arm attached to that. And so this is our pivot point. So we need something attached to that pivot. So we're going to take another cube, and this one needs to be smaller. I think we could just use 5 for that. That's going to be centered. So if we want it to be at 2.5, that means it will align exactly with the edge of that. And so what we can do is we can actually spin this, and you'll see it kind of pivots around the edge of that other one. And so let's see here. The other thing that I want to do is actually take this cube and shift it over 5, and shift this one over 10. This way, we have our pivot point is at the 0, 0, so right there. And then everything else kind of bases around it. So just to make it a little bit easier, let's drop in a cylinder here. Sure, I don't really care about everything else. We can actually drop a second one right at the other pivot point, just so those are a little bit more visualized, and it will cover up some of the things not aligning because we're just using squares. And so this way we get our 2 arms. And so what I want to do is create a script that's going to apply some sort of velocity or rotational force to those. So in the actual thing, we'll probably use like stepper motors or something to control this, or some other mechanical thing. It's not something that I'm very familiar with. So I don't actually know the solution, but we need to rotate these. And if we rotate them either together or separately, we should get some sort of cool, fancy pattern. So the other thing, while we're here, let's add a final game object. Let's move it over 5 more and add a trail. And so we're going to do a trail render. I'm not going to apply material yet. We're just going to get this purple trail, but hopefully we'll get some sort of unique pattern. And this will kind of let us see the trail that our I guess ball in this case would go. In the final solution, this mechanism would sit underneath, and so you wouldn't actually see this. The magnets is what is going to actually provide all the movement. And so, yeah, I don't know. So let's do a script here. So I tend to stick everything in a scripts folder just so that I don't have code amongst everything else. For me, it helps keep everything kind of isolated, but that's just me. So let's just do a basic like rotation. Basic rotator. Let's not call it basic. That's not very descriptive. Let's do a fixed rotator. And so that's going to rotate something by a fixed amount every second. And so what we want is to open code and do some sort of amount. So we're going to do public float speed. Speed is always a good name, I guess, if you don't know what you're talking about. This transform dot rotate. Let's see here. Rotate around. We can rotate around an axis, or we can just rotate it on the y-axis. So let's try that and see what happens here. Let's see here. We can give it x, y, and z. So let's do the speed times our time times the delta time, and give it another 0 there. There we go. And I think that's everything we need to rotate it. I've never actually used that in a while, so we'll see. But the first thing we need to do is actually rotate the entire thing. So that's going to be the rotation of the first arm. So we'll just give that like 10. Making these numbers up, that's going to be too slow, actually. Let's do 40. Because these are going to be degrees per second. So at 40, that's going to take probably too long as well. Let's do 90. That means 4 seconds it will do a full rotation. That might be too fast, but it meh. And then for the fixed rotator, for the second one, let's do negative 60? Something like that. And so if I were to run this, something will happen, right? All right, it's a little bit, like our sequence is a little bit weird, But you kind of get the idea, right? So we're rotating these and they're attached to one another. So they're actually creating these patterns. If we were to extend the length of this, like say 100, we should get some cool like spiral going. And we'll get to see the pattern that should create. Because I use multiples of one another, we're probably, yeah, we're going to get that pattern. But we can actually change these and get different things. So if I make this, say, 270, now we should get a much more different pattern. Still not very interesting. We're getting those 3 spikes because 90 and 270 go into one another. Let's do something that can't be as easily divided. And let's do like 300. And so the general idea here is there's going to be like these gates. At least the idea of the game that I'm picturing is there's going to be gates that are going to spawn. And so you can see it's kind of moving around this circle. And so the idea is you'll be able to control the speed of both of these rotations, but you won't be able to go backwards. And so you can make it rotate slower and have like a less points, or you can make it rotate faster and kind of get through things faster. And so the idea is there's going to be gates that are going to close, and you need to figure out how to maneuver the math to get that through the gates. I think that makes sense. Whether it actually works or not, I don't actually know. But, you know, it's an experiment. And so as we like change these, we should get like very vastly different patterns, I think. And as that gets closer to 0, it should get more or less like just a spiral. Yeah, okay. So that is sort of like, I guess, the first step. What I want to finish in this video before kind of moving on and getting the rest of it going, we're not going to do the gates in this video. We're not going to do a lot of things. We're not really going to get the game part, but we are going to get to the point where we can adjust the speeds of our rotators. And so let's grab, do you want it to be a fixed rotator, or do we want it to be something else? I'm trying to think of how we want to actually influence this rotation. Obviously I have a keyboard here, but we're not going to have a keyboard in this final thing. So instead, I think it might make sense to do some sort of like increment and decrement of these two things. And so what we can do is do a speed modifier. There we go. And this is going to have a reference to a public fixed rotator. And this will be the rotator. And then a public int step. So I don't want this to be like a fine-grained thing. Maybe that makes more sense, where you can just like turn something so that it goes either faster or slower. That might work, but also it becomes more difficult to like predict the movement. And so if we do a step, then we can just have like a increment or decrement button. But then the patterns become less, like there's less variety there. So let's actually not do that. Let's do a float. And this will be our rotation value. And that's going to be between a 0 and 1. So let's actually do a range. This isn't actually going to impact anything in the script. It is going to impact Unity, though. Unity's inspector is going to see this range label and say this can only have values between 0 and 1. So it's actually going to give us a slider for this value instead of the normal enter any number here. And if we try to enter something outside of that, it should automatically clamp us in the inspector. If we try to set it from a script, it's not going to look at that. But from Unity's inspector, it gives us a nice way to kind of control that a little bit more. And so the other thing is going to be a min value and a max value. And so we can just do a lerp between the min and max with our rotation value to actually get the real rotation of this. And so how do we want to do this? I'm thinking of pulling in Unity's UI stuff, but it's been a while since I've worked with that. And I haven't worked with the sliders in a while. So I don't actually know what we're gonna get when I try to do this. But if I create a new slider, that's gonna create a new canvas and put that in there. And what kind of canvas is this? It looks like a screen space overlay, which means if I go into our game, we have this little slider here. And that's going to overlay over the top of whatever we're drawing. That's really small, so we're gonna make it bigger. Let's see here. 320? Just guessing at sizes here. That's wrong. All right. It'll be fine for tests. This is probably very small for the video, though. All right. And so with this, how does this work? On single value changed, we are going to want to bind to two different speed modifiers. So I'm going to attach them to each of these scripts. And it's not compiling for some reason. Fixed rotator. What? Our type doesn't exist. Did I spell this wrong? Oh, I did the mono behavior thing. One of these is spelled incorrectly, but I don't actually know which one it is. And this is great. We have an O and we have an E. Pretty sure it's an O, but we're gonna do the E. So, yeah, naming is hard, and I did it wrong. So, all right. So fixed rotator, set that there, and then here we're gonna set that. Now these sliders have one event. It looks like, which is on the value changed. And so the way a lot of these UI systems work, and this isn't specific to Unity's UI, if you're using like Android or XAML or anything else, it's going to be fairly similar. There are events that are going to trigger something in your code. And so generally the reason behind that is we interact with things slowly. Like if we're talking about a keyboard, the number of keys that you can press a second is much lower than the number of frames your computer is running at. And so it doesn't make a lot of sense in most cases to have your UI constantly checking for every new change all the time and having those be constantly triggered. So like with games, we put things in our update loop, right? But with the UI, you're looking for things like button presses and like single events. In this case, it's going to be the value changed. And so that really only triggers when we let go of that slider. And so we don't actually need to constantly check and constantly be triggering all these updates and running all of this extra code for these events that happen very infrequently as far as computers are concerned. And so that's a lot of the reason that events are used. They also make it really handy for attaching lots of different events from different objects onto the same trigger. And so we can have a lot of things happen from a single source, in this case our UI. So that's part of the reason that those designs exist. There's other things probably, but at least for me that seems like the most useful reason for that functionality to be the way that it is. So what we want to do is change the speed of the rotation of this first object. And we don't have a function for that. Like it doesn't exist. And so how does this work? I think it gets passed in a single value. I'm guessing here, but it's saying it's passing in a single. And so that's going to be a type of float. So if we do, is it a type of float? I may be wrong there. I'm pretty sure it's a type of float. So we're going to pass in a update speed method that is going to accept one float value, which is going to be the new value of our slider. And this is going to be the new speed. And so what that's going to do is set our rotation value equal to the new speed. Now I think we didn't need to do that. I think we could just set the public value of that. Maybe we could use a property or something, but I think this makes the most sense. So let's see, we have tag, all of these. Speed modifier, update speed. And we're going to pass in our new speed value. Like that. And it expects a float. Why? What's going on there? I don't know. I had sort of assumed that would send the updated thing. I'm going to actually look at the documentation for this. So I will be right back and hopefully have a better answer. Okay, I'm a little confused on this. I'm right, I think. and we should be getting a float parameter here for this. But according to the docs, it should be passed in for us, and I must be doing something weird. The event can send the current value as a float type dynamic argument. I don't know what that last bit means, but I'm assuming it means we're going to send you a float. But why can I change the value of the float? The value is passed as a float type regardless of whether whole numbers is enabled or not. So whole numbers is going to be this thing. And I'm assuming, yeah, whole numbers is going to be rounding versus not. So we get between 0 and 1. So I'm curious now. It has a float here. I'm not sure if we're always going to get 0. Like, I would assume we'd always get 0 based off of this. And that's not what we want. We don't want to always send a constant float value. We do want to send a dynamic one based off of whatever the value we're using is. And so if I do this right, which I'm not, but we should be able to put a breakpoint here and then run this and get some result. So this is going to rotate, and then if I hit that, what? We don't even what? Hold on. Nothing makes sense anymore. Speed modifier, update speed. Breakpoint. What? Are we not in? How are we not calling this function? I'm extremely lost right now. Our event isn't getting called for some reason, but I don't know what that reason is, which is a weird thing. I don't have a good answer here. This should be calling the speed modifier update speed. We should be getting an event trigger, which means that we should be calling this function. But we're not. At least we're not hitting the breakpoints. Oh. We don't have a debugger attached. That's important. This UI has changed since I last used it, so we'll see what's happening here. We're going to create a launch JSON, create a Unity debugger. I have a thing that automatically does this for me. There's a Unity extension that will let you generate this launch.json, which is required by Visual Studio Code in order to attach a debugger to other things. And then we need to select what we want to attach to, Unity Editor, and just click Run. There we go. All right. What do we get here? So now if I change this, we break. Perfect. But we get 0, which isn't what we want. So we're getting a constant value back out. I don't know how to fix that. because I didn't set it to 0, I didn't set it all the way to the left, so we should expect a different a value that is non-zero. But we definitely got 0, unless no, it's back to running. And so you can see we got like 0.79 as our value, but we passed in 0. And that isn't what we want. Oh, what? Okay, hold on. They've changed this UI. So dynamic float is going to be using the value from this update speed. The other one allows us to provide our own static value. So if we want to use our own value here. Okay. So now that I've changed this, I don't know what value I set it to, but we should get something non-zero. Perfect. All right, so that's working now. So I was just doing it wrong. So we can detach that debugger, go back here, and now we should be able to update this. So this is going to set our rotation speed to that. We also need to update our fixed rotator. So do our rotator, nowhere, I guess, dot speed equals, we're just going to do a lerp. Lerp is linear interpolation, which is going to move between two values. So if we have a min value as our lower bound and our max value as our upper bound, if we put 0 or 1 into this t value, we're going to get somewhere in between those two. So we're just going to plug in our rotation value right there. And now since that is bound between 0 and 1, if we plug in 0, we should get our min value. If we plug in 1, we'll get our max value. And if we plug in like 0.5, we'll get halfway in between. This is a linear interpolation. There are other types of interpolations like slurps, which is going to be a spherical one. That's more useful for rotations, but for us, this is exactly what we want. So it's perfect. And so we plug that in. That will update the rotation, and we should be good. So the only other thing we need is another slider. So I just need to move this down a little bit. Sure. And we need to point this at a different game object. That one. And plug it in for the dynamic speed modifier update speed. Perfect. And now we should be able to change both of those. I don't know if I've set the min and max value. I haven't. So let's do 10 and 360. So a full revolution every second, which is going to be way faster than whatever I build, like realistically is going to support, but we'll have it there for fun. And we will do 30 and 180 for the other one. So they're a little bit different, but that should give us a little bit of a better idea. And then we can actually, because this is actually a screen overlay, it's going to move with our camera. So I should be able to take this and move it up and then rotate it down like this. We need to go a little bit higher because I made this huge. But this should actually give us like a really good picture of like what we're actually getting out of this. So let's make this a little bit nicer. Material, random material. It doesn't particularly matter what we're doing here, but let's just attach a particle. The reason I'm using a particle here is because it's actually going to be it's going to support transparency, and so we want this. I want this to slowly fade out as we move this. And so if we take this game object and attach our material wherever it goes, not there. There we go. Now we should actually get some nice-ish looks. We just need to, I guess we can just do that and slowly fade out the opacity over time as well. So something like that. It's really rough. It's not intended to be like something super specific, but if we do like a 60-second thing like this, we should get some interesting patterns from this, hopefully. Not really sure exactly what to expect, but there's our default. It's pretty boring, but if we increase this, it went the wrong way. Why is it rotating slow? Okay, that one's faster. that doesn't seem to be doing anything. Ah, that's why. I had changed this while I was playing, so it didn't update. So we're going to move it back to the dynamic thing. That should give us a much better results. And so we should actually be able to modify this instead of setting it to 0. All right, so we have this. Let's increase the speed and this speed. And we have another one of those sync ups, so we can mess with it some more, and we get this. Yeah, I think this is cool, especially when we add this. Like, I'm really interested to see what will happen if we put this over sand, because it will sort of maintain its shape, and so you should actually be able to see all of the previous trails of the path of this. So just like it's sort of fading out here, that's sort of what I'm hoping will actually happen in the actual thing. And so yeah, I think this gives it sort of a fun way to kind of manipulate this. Whether it actually works, I have no idea. It's a very different thing, like I was kind of talking about earlier, going between digital 2D screen and other things. So I'm hoping to build the full thing in Unity and get it working and like fun, and then go and actually invest in the resources required to actually like physically build it, because that's where the actual cost of this project comes in. Like right now, it doesn't cost me anything to play with this other than my time. But once we actually start dealing with like actual things, we're going to be talking about like real materials and like actual electronics that I'm going to have to like pull apart and do all this other stuff with. And those cost money. So we're going to do it the cheap way first. And I think that's pretty much that. So I'll leave it here. I think this is really all I wanted to talk about. I will leave some links in the description to like Line Wobbler and a few other things. So yeah, if you have ideas or suggestions or feedback or whatever, this would be a project where it would be really handy, because once we actually start building the thing, it's going to be really hard to like go back and like completely change direction. This gives us a way to like, if we get halfway through this and realize it's a bad idea, we can just go a different direction. But once we actually commit, we can't really do that, at least not as easily. So yeah, I think that's mostly it. If you like the channel and you like this kind of content, maybe consider subscribing if you haven't already. And if you like the video, consider giving it a thumbs up. Other than that, we have a Discord channel. There's a link to that in the description if you want to join that and talk about programming or games or other random things. Yeah, we'd love to have you. So that's it for this video. So until next time, see you, Internet.